Okay, this problem is going to be an example that you can use to be able to solve titration problems. It's also an example that you can use to solve some neutralization problems that you're going to encounter during the course of this unit. What's kind of fun about this is that it's going to be, these are the same two substances, your sodium hydroxide and your hydrochloric acid are the same two substances that we're going to use in the lab, so it makes it kind of simple, okay? Another thing too, it really gets me to know that you understand what concentration means, what reaction stoichiometry deals with, and so on. So it's kind of a culmination of everything that we've done so far in this class, frankly, okay? So if we're given a problem something like this where it says how many milliliters, okay, of 0.40 molar hydrochloric acid are required to neutralize 0.5 liters of 0.4 molar solution of sodium hydroxide. Okay, so when you have something like that, here's some interesting things. Okay, we're going to, as we always do, we're going to write down our givens, okay, our unknown, and then our basic equation or pathway. Okay, obviously our given here is we have a hydrochloric acid solution 0.40 molar HCl. Okay, we also have a 0.40 molar NaOH, and it is taking 0.45 liters of the sodium hydroxide to neutralize that hydrochloric acid, okay? To neutralize that hydrochloric acid. So you got to keep that in mind here. And I'm going to move this around here a little bit so we can see it a little better. Okay, our unknown is the number of milliliters of HCl are required to neutralize that particular volume of concentration of sodium hydroxide. Okay, now our basic equation or pathway, we've got to kind of think this through a little bit, but if you understand molarity and you understand how to do this, it really is very simple. Okay, I've got to somehow get from the number from my volume and molarity. This should be an and molarity of my base, my NaOH, to my volume of my acid. Now, I can't just do that, okay? I can't just, make a nice conversion type of a problem to do that. So I've got several steps that I've got to do. So when I look and I evaluate this particular problem, here's what I know I'm going to have to do. The first thing I'm going to have to do is I'm going to have to determine my number of moles of NaOH from that volume. Of NaOH, okay? And then I know this. I know that any neutralization reaction, whenever I have an acid plus a base, so this is the equation here, HCl plus my NaOH, this is a plus, by the way, that's going to react to yield a salt, sodium chloride, plus water. This is the old double replacement, and I'm leaving out phases here, folks, because I'm cheating a little bit. Okay, obviously we have aqueous over here on this side, and then we're going to have an aqueous solution here, and this is just going to be water, going to be liquid. I'm leaving those out for time and so on, okay? So I know that I need to use reaction stoichiometry principles here and make sure that my equation is balanced. Well, this is going to be a balanced chemical equation here, because I know that once that I find my number of moles of sodium hydroxide, I can then go from number of moles of sodium hydroxide using stoichiometry. I can go to a number of moles of hydrochloric acid. Okay, all right. So I would have to be able to do that, and the only way to do that is use that molar volume from the, or use that molar ratio from the equation, not molar volume, molar ratio from the equation. That molar ratio from the equation. Okay. Then with that knowledge of that stoichiometry, figure out my number of moles of hydrochloric acid. If I have, the number of moles of hydrochloric acid, if I have the molarity, okay, of the hydrochloric acid, I should then be able to determine number of milliliters okay, as is asked up here. It'll actually be first in the form of liters, and then I'm going to have to go from liters to milliliters. But that's pretty simple. That's a pretty simple thing to do. Okay, so we'll create a new page here and kind of clean things up, and we'll just solve this darn problem. Okay, so here's how I would start this out. I know that I've got 0.45 liters of my sodium hydroxide. That's the hydroxide. Okay. I also know that I have got 0.4 molar. What that means is I've got 0.4, gosh, that's ugly, 0 moles of sodium hydroxide for every 1 liter. That allows me to factor out my liters. So that's going to leave me with 0.18, this is a point, mole of sodium hydroxide. Okay, so that's that first step of that, okay, that we talked about. I've got to determine my number of moles of sodium hydroxide. Well, that's what I've done, okay. Well, if I have my number of moles of sodium hydroxide, I know that I have a 1-to-1 ratio, but I'm going to go ahead and do the math associated with that in terms of ratio of sodium hydroxide to ratio of hydrochloric acid. So I got 0.18 mole of NaOH. I know that through the equation, for every 1 mole of hydrochloric acid, or pardon me, of sodium hydroxide, I got 1 mole of hydrochloric acid. So that means I'm going to that's going to factor out my labels here. So that means I should have 0.18 mole of hydrochloric acid. Okay. Now, in this particular equation, if I'm given a molarity, then, okay, if I'm given a molarity, if I have a molarity of 0.40 molar hydrochloric acid, and I know that I've got 0.18 moles, it should take 0.18 moles of hydrochloric acid over X liter, because that's what molarity equals. Then when I solve for my X liters, I've got 0.18 mole of hydrochloric acid divided by 0.40 mole of hydrochloric acid over 1 liter, because that's what molarity stands for. Factor out my moles, okay, leaves me with that complex fraction of 1 over liters, which if you invert multiply, obviously, to factor out that label, okay, so nothing it serves as a complex fraction, so we're going to end up with 0.45 liters of hydrochloric acid, okay, which is going to be 450 milliliters of hydrochloric acid. All right, so when you look at that, our answer here is the same number of moles, or pardon me, of milliliters as what we started out with in the problem, and that goes back to understanding that our molar ratio here is a 1-to-1 molar ratio, and if I've got the same molarity here on both sides, and it is a 1-to-1, okay, it's going to take the same number of milliliters or liters. So very, very simple problem. I'm going to do one a little more complex, but not really. Enjoy, have fun, and practice.